go. What's the angle between BC and AC? Let's name it. Here we go. BC and AC, number 4. Angle C, yep. What's the side that includes angle B? Side that includes angle B, 3. Yep, and AB and CB. Yep. Again, you guys see I have AB up here. You could have had BA, same line segment. What angles include line segment BA now? Line segment AB, 13. How about 19? On fire. How about 14? There we go. 3. Angle A and angle B, yep. Okay, and then finally, what side includes angle A and angle C? 19? 13. 2.
AC.
Line AC or segment AC. Any issues so far? Okay, what'd you put in for the proof then? I'm hoping this was basic. This is, I don't know if other than writing in the word given, how basic it can get. 12, what do you got for your steps? Given, yep. Yep. Anything else? Okay, how'd we look for pages 16? That was the graph. Oh, we didn't do. Go ahead, try the proof out then. Top of the page. Top of page 16. Let's try that proof out. Let's see what we have. How about 18? Segment, angle, what are we talking about here? Angle, say them again. Yep, congruent to? Congruent to GFH because? There you go, those are vertical angles. That should give you enough information now to say the triangles are congruent. Triangle DFE congruent to triangle HFG by what method here? What method we looking at? Here we go, 20. Side angle side. Okay. Everyone all right here before we pick up the pace as far as the difficulty of these proofs go now? Questions? Okay, I told you there's 5 different ways to prove the triangle's congruent. Friday, we went over 2 methods. Friday were the first 2 methods, which just remind myself and your classmates. 7, what are those 2 methods? All right. Where's that angle have to be? In side angle side? In between the 2 sides, yes. Do you see any alternate version of side angle side up here? Like side angle or angle side? No, you don't. There will never be. That angle has to be in between. If it's not, we're done. We can't do it. All right? 3rd and 4th method today. 3rd and 4th method. Angle, side, angle. Angle, side, angle. And it is written in that specific order. Why? Where's the side have to be? In the middle again. Yes. Just like side angle side. And this time, though, the side has to be in between the 2 angles, as you can see from the diagram I provided here. Okay, the side needs to be in between. But if it's not, that's okay. Because remember on Friday, if the angle was not in between, it would be no shot. We're done. But now, hey, let's say that side's not in between. That's still okay. They're still congruent. We just don't use angle, side, angle. We use angle, angle, side. So if the side's not in between, it's still good. It's still good. We just have to use a different reason called angle, angle, side. Bottom line, you got two pairs of angles and a pair of sides, you're good to go. The tough part is figuring out which one to use. But if you have two pairs of angles and a pair of sides, you're good. All right, I got two proofs we're going to do as a group, and then I'm going to leave you to do another one with your group, and then we're going to have a group presented, a random group presented up here. Okay? So go ahead, get your givens, get everything you need marked right now for this first proof. And I still cringe every time I see bisects because I'm wondering if we picked this up yet. Okay, you guys ready here? Got everything in the givens. But the only thing, take a look at my diagram. The only thing I marked was these angles congruent. I didn't mark the whole bisects thing because I want to pull that from you. All right. Also, because we are starting off on, we now have 4 methods, I'm going to try to keep things organized. You can follow this if you'd like. If not, if you don't like it at all, don't do it. This is a full pair of angles in each triangle, correct? So what I'm going to start doing is I'm going to mark that with an A in parentheses that tells me, hey, you already have a pair of angles congruent. Okay, so that's what I'm going to start doing, just so I can keep track of what I have already, because these proofs are going to start to get longer and longer now. So I already have a full pair of angles, which means you guys are on the hook for 2 more pair of something. Sides or angles, I don't know. Okay, you guys are on the hook right now for it. Where are they coming from? Let's do this. Where are those sides and angles coming from? Here we go. 5.
Line PS is root to line SR.
Why? You guys are killing me. Guys are killing me. Like, what is getting bisected? Is a side getting bisected? Then don't tell me sides are equal. All right, that's why I cringed earlier. What angles are congruent?
RQS.
There you go. Angle RQS congruent to angle PQS. Definition of a bisector. Are we all good there, guys? You got to know what's being bisected. Got to know what's being bisected. And right there, that gives me a second pair of full angles. Now, as I'm starting to do this proof, I have 2 pairs of angles. Is angle, angle, angle a way I've shown you so far? Absolutely not. So you know what's got to come next is a side. You know it's not the 3rd pair of angles because angle, angle, angle is not a way. So it's got to be some side up here. What is it? 5 again.
Would it be SQ?
There you go. Because of reflexive, yep. And there is my side. Now this is the tough part. You guys have to decide, is that side in between or not? Okay. Is that reflexive side in between my 2 pairs of congruent angles? So that's going to be the toughest part about this. So what do we got? Is that side in between? Yes or no here? Here we go. 9?
Yes.
Yes, it is. So I want to use
Angle, side,
angle, side, angle. Any questions on this one? Using the bisector or reflexive? Because then now it's going to start getting a little tougher. Go ahead, Cameron.
Does it matter what order you do this in?
No, you could have said the reflexive first. Absolutely does not matter. as long as all of them come before the angle side angle. Order does not matter. Okay, for this next one, does everybody see how I start overlapping triangles now? Everyone see that? To make it easier on the eyes, I think, if you have colored pencils or highlighters, you may want to highlight both triangles in a different color, just so it's a little bit easier to look at with the eyes. Okay, so if you don't have them today, that's fine. Maybe, and again, you only need 2 different colors. That's it. I'm not asking for a full box of colored pencils. So A, C, D. And ECB. And all I do with those colored pencils is highlight the 2 triangles. That's it. Just so I can see where they are. All right, so I'll give you guys a second. Fill in your givens. If you want to mark anything on your diagram, feel free so we can talk. Let's start with the givens, because maybe they provided us with full sides and angles. Let's see. Angle DAC, this angle right here, is congruent to BEC, this one right there. Guys, are those 2 full angles in each triangle? Is that a full angle in each of the triangles? Everyone agrees yes. So that has provided me with at least 1 pair of angles. And it's got to be full. Can't be partial. Got to be full. Okay. Are DC and BC full sides in each of the triangles? I see some people shaking their head yes and some people saying no. Well, hey, ready? DC, that's a full one in my yellow one up here. That's why colors are important here. I see BC is a full one in the pink one. So yes, that gave me a full pair of sides. This isn't bad, because what are you guys on the hook for? 1 more pair. You're on the hook for, you need usually 3. I gave you 2. You're on the hook for 1 more pair of sides or angles. I can't really tell just based on what I was given. It could be sides, could be angles. I don't know. Okay, I'm going to give this one away right from the get-go, so I'm not going to force you to look for it. You guys are so used to using reflexive for a common side. It can also be used for a common angle. Okay, reflexive can also be used for angles. Do you guys see a full angle that both triangles share in that diagram? Okay, do you see it? Not a partial one, a full angle both of those guys share. And it would be, who's got 6? Angle C, everyone. Take a look. Angle C, shared by both. And I usually don't put an X for reflexive angles. So angle C is congruent to itself because of reflexive. And that gives us another pair of angles. So the tough part, now that I know the triangles are congruent, the tough part's going to be angle, side angle, 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 side. And you cannot go by the way you listed them. Okay, you cannot go by that way. That's tough to figure out just by looking at it. Is that angle in between? Is it not? I don't know. Is the side in between? I don't know. Ready for my little suggestion? Draw out one of the triangles. Take one of the triangles, draw them out. All right, so I'm going to take triangle ADC right now. So I'll take triangle ADC, and it doesn't have to be anything fancy. So here's triangle ADC. Put whatever markings you put on it. Let's see, we did what? Angle C, right? We put a marking on. What else did we put a marking on triangle ADC? Where else do I have markings on my diagram? On DC, okay, and where else? On angle. Makes this discussion real easy now, doesn't it? Is that side in between or no? Nope, so I know it's got to be angle, angle, side. Makes things a lot easier to look at when you draw out one of the triangles and label it with whatever your labels were. Emily, a question? My what? Oh, this one, ADC? That was my triangle in yellow, was ADC. Okay. Questions? At the bottom of the page is just a summary of the 4 methods we've done so far over Friday and today. What you're going to do now is you're going to go to the very back of your packet. You got a blank room to work there. I'm going to give you a proof right now that is not in your packet and is about as difficult as I can give you. All right, you're going to work within your groups right now. Get after it. I'm going to select one person from the number generator, and that person and their entire group are going to come up and write what they got for their proof. Okay? And that's what you got for the remainder of the class period here. So there it is. There's the proof. Whoops. There's the diagram, your givens, and the 2 triangles you need to prove congruent. Okay? If you guys can get this one, feel pretty confident in yourself, because this is about as tough as I can give you at this point in the unit. Okay. If you get really stuck, call me over. I'll give you a hint, but I prefer not to give out the hints. I'd rather you guys just talk it out. You may be using reasons we haven't used in a couple weeks, but they're still there. All right, anything from units 1 through 3 can be used. First thing I would discuss in your group is what are full sides or angles we're already given and how many do we have to find on our own. Okay, that's what I would discuss first. How many full sides or angles did I give you? How many do we have to find on our own? Okay. Okay, let's see what they did here. First, they said 3 and 4 were supplementary, 5 and 6 were supplementary because linear pairs are supplementary. Good. Congruent angles have congruent supplements. Supplements of congruent pairs are congruent. That's fine. I maybe just put angles there instead. That's fine. Supplements of congruent angles are congruent. That's how you get 4 and 5 congruent. And that gave you a second pair. MRO congruent to itself, true. And then you needed to subtract it to get those pair of angles. So that gave you the other pair. And that side is in between those 2 angles, so that's why they used angle, side, angle. Now, if you did the linear pairs and supplementary angles second and did the subtraction first, that's fine. Okay? Make sure you got reflexive in there before you subtract, because how many pairs of equal quantities do you need to subtract? 2, and that second pair was MRO and MRO. Anything you guys would like to add on to what they did? Nice job, group. This is about as tough as it can get, right, as at this point anyway. As tough as it can get. Okay, I'm asking you guys for 5 problems tonight, so it shouldn't be too much work. All right. Get in here if you're worried about the proofs.